So we're going to continue looking at the properties of specific quadrilaterals. So the first quadrilateral we're going to look at today in this video is a rectangle. So a rectangle has a couple special properties. First off, it has all those 5 properties that a parallelogram has, but it also has 2 special properties of its own. The first property is that the diagonals are going to be congruent to each other, and the angles in a rectangle are all right angles. So those are the 2 special properties that a rectangle has that not all parallelograms have. Okay, so let's take a look at an example here to see if we can show a shape as a rectangle on the coordinate plane. So this problem wants us to show, is ABCD actually a rectangle? To show this, we need to show 2 things. One, we need to first see, is it a parallelogram? So we need to show that opposite sides are parallel. And 2, we need to show that adjacent sides are perpendicular. We're doing that because if the sides are perpendicular, then all the angles are right angles. So remember, to show that opposite sides are parallel, we need to show that they have the same slope and to show that adjacent sides are perpendicular, we need to show that those sides have opposite reciprocal slopes. Alright, so all we have to do is really then find the slopes of all the sides. So let's get started with that. Let's start AB. So AB has a slope of, and again we just have to find rise over run, so 2 and 6. So AB has a slope of 2 over 6. And then the opposite side of AD, BC, its slope is, again, rise over run. So in this case, we're going to go down 2 and left 6. But it also has a slope of 2 over 6. Because if I have a negative 2 over negative 6, that's going to simplify to positive 2 over 6. Alright, and now we just look at the other pair of sides here. And that pair of sides is AB. So look at that. Rise is negative 3. Run is 1. So AB has a slope of negative 3 over 1. And if we look at DC, we're going to do the same thing. This has a slope of rise 3 and left 1. So there's a slope of 3 over negative 1, which is the same as negative 3 and negative 3. To compare these slopes, if we look, AB and BC have the same slope, so they are parallel to each other. And then also, AB and DC have the same slope, so they're parallel to each other. So this is our first step. This shows that the opposite sides are parallel. Okay. Then the other piece of information that we need to look at is, are the sides actually perpendicular? So to do that, what we're going to need to do is actually simplify our slopes here. So this slope of 2, 6 is simplified to 1/3. This is simplified to 1/3. And so if we look, AD is a consecutive side with AB. So these two compared to each other. Let's fix that 3. Those compare to each other. So those 1/3 and -3, those are definitely opposite reciprocals. So we can say that AD is in fact perpendicular to AB. And then if we compare BC to DC, again, the two consecutive sides or adjacent sides, 1/3 to -3, that those are also opposite reciprocal slopes. So BC is in fact perpendicular to DC. And since that is true, that proves that the adjacent sides are perpendicular. And with that being true, we can then say that ABCD is a rectangle because opposite sides are parallel and all angles are 90 degrees. And that's because we know those sides are perpendicular, which means they have to be 90 degrees. Alright, so we've now proven that ABCD is in fact a rectangle. Let's look at one more problem here. And this next problem, we're going to look at a rhombus. So a rhombus is again a parallelogram, but all four sides have to be congruent for it to be a rhombus. So all the properties of a parallelogram for congruent sides. One other neat property is that the diagonals are always going to be perpendicular to each other. Okay, so let's look at our rhombus. The key feature being that it has four congruent sides. So here we have the shape in the coordinate plane, ABCD, and they want us to show that this shape is in fact a rhombus. So to do that, we have to show that one key feature, that all four sides are congruent to each other. So looking at our four sides, we have AB, we have BC, DC, and AD. Now, to do this, we could use the distance formula, but I always find it easier to do the Pythagorean theorem. So let's look at each side and use Pythagorean theorem to find the distance. So our first side, AB. So look at AB. We're going to make a little triangle here that has a side length of 2 and a side length of 3. So to get our distance, or our length of that, it's going to be the square root of 2 squared plus 3 squared. And that will give us 4 plus 9, or the square root of 13. Now we'll do the same for side BC. So BC, our distance here is going to be side length of 3 and the side length of 2. So it's going to be the square root of 3 squared plus 2 squared, which again will give us the square root of 13. And then let's keep going around here. We'll look at side DC. So side DC has a length of 2 and a length of 3. So to get its distance, we will do the square root of 3 squared plus 2 squared. And again, that gives us a square root of 13. And then finally, our last side here, DA. So for DA, we're going up 3 and over 2. So that's going to have a distance of the square root of 3 squared plus 2 squared, or the square root of 13. So if you look, all four sides are congruent to each other. They're all the square root of 13. So we can say that in fact that ABCD must be a rhombus because all four sides are the same length. Alright, so that is a rhombus. We have one last shape to take a look at, a square. Now, a square is really special because It has all the properties of a parallelogram, so those 5 properties. It has all the properties of a rectangle, so the fact that it has right angles. And it also has all the properties of a rhombus. So I like to think of this square as kind of like if a rectangle and a rhombus came together, they would make a square, where all 4 sides are the same and it has right angles. So what we need to do to prove that this shape ABCD is in fact a square, we need to prove 2 things. 1, that all 4 sides are congruent. That's that rhombus coming out. But we also need to prove that all 4 angles are 90 degrees. So to do the all 4 sides congruent, that's just the distance formula, or the Pythagorean theorem, however you want to think about it. And then to prove all 4 angles are 90 degrees, we need to show that adjacent sides are perpendicular. And we do that by finding the slope, meaning opposite reciprocal slopes. So slopes are opposite reciprocal. Let's get started. We're going to find the slope and the length of each side. Start here at AB. AB, that's going to have a slope of -3, +1. M is -3, +1. And to get our distance, it's actually kind of cool. We can actually use these numbers of an unsimplified slope, -3 squared plus 1 squared, because those are really the dimensions of the right triangle, and that's going to give us the square root of 10. Alright, so there's AB. Do the next side here. Let's go B to C. Slope of -1 and -3. BC. Slope is -1 over -3, which simplifies to just 1/3. And our distance would then be, again, using those slope values there, 1 squared plus 3 squared, which is, in fact, the square root of 10. Alright, off to a good start here. Let's find the other 2 sides. CD. CD, its slope, we have a rise of 3, so that's +3, and a run of left 1, so that's -1. So -3 over 1. And then we have a distance. Again, we can use those non-simplified slope values of +3 squared plus -1 squared, and that gets us a square root, 9 plus 1, or 10. DA, the side DA, slope of that side is going to be up 1 and +3 to the right. So it has a rise of 1, a run of 3, so a slope of 1/3. And then our distance, again, using those unsimplified slope values, we get 1 squared plus 3 squared, which in fact is the square root of 10. Alright, so we can instantly see that all 4 sides have the same length. AB is congruent to BC, which is congruent to CD, which is congruent to DA. Okay, so that's the first part. Now the second part is looking at the slopes of the consecutive sides. So AB is consecutive to BC, CD consecutive to DA. We can say that because their slopes are opposite reciprocals, that AB is going to be perpendicular to BC, and CD is going to be perpendicular to DA. And because those things are true, DA is also going to be perpendicular to AB, and CD will also be perpendicular to BC. But because we already know the other 2 are true, those following 2 must also be true. So with all of this information here, we can say that ABCD is a square because all angles are right angles and all sides are congruent. So we need both those things to be true, because if just all sides were congruent, it could be a rhombus. And if all we knew is that all four angles were right angles, it could just be a rectangle. So we need to prove both of those things are true. All angles are right angles and all sides are congruent for us to know that it is exactly a square. Couple examples there. Come back to the next video to take a look at what your practice is for today.